All right, everybody, welcome to episode 26 of my multi-cloud network architecture series. And in this episode, I've brought special guest Abhishek. Abhishek is part of our awesome professional services team within Aviatrix. And what they're doing all day long is building new architectures, helping with brownfield migrations from existing environments to Aviatrix Enterprise Class Transit. And that's what we're going to focus on today. We have a lot of customers coming to us moving away from traditional do-it-yourself transit solutions like the AWS Transit Gateway to a true enterprise class transit from Aviatrix. And we've got that process down perfectly. So today, Abhishek is going to show us how his team does this all day long for our customers. Abhishek, thank you so much for being here with me today.
Thanks, Dana. Happy to be here.
So, Abhishek, tell me why customers are moving away from this do-it-yourself approach using solutions like the TGW to Aviatrix Enterprise Class Transit. What are all the benefits that they're seeing that make them make this move?
Yeah, that's a great question, Dana. And conversations that we have with different customers every day. Native CSP solutions, AWS Transit Gateway specifically, customers realize that they don't really offer enterprise-grade networking. Things like dynamic routing, high performance, visibility is a big one, and then just the overall ability for customers to manage a large environment. That's something that native solutions just don't offer. And once customers are introduced to the Aviatrix Transit, they see what Aviatrix offers and why the Aviatrix solution is enterprise grade.
Yeah, Abhishek, what I'm finding is that the organizations that started with the do-it-yourself approach are finding that it doesn't scale. As they grow their network in the cloud, they're having to also grow their cloud team, right? They're having to add more and more people to this environment, to manage this environment, to manage the whole manual do-it-yourself approach. It isn't efficient. It's super hard to manage this at scale, and there's no intelligence built into these do-it-yourself approaches. So I'm finding that customers are realizing that a controller based approach gives them all the built in intelligence to scale this up really quickly and to manage it at scale. So, manageability at scale is really important. We can't just keep adding more and more individuals, more and more people to an environment to manage the cloud, right? That doesn't scale from a financial perspective, right?
And Dana, don't forget, a lot of customers also struggle getting support and attention from a lot of these CSPs. Aviatrix has one of the best support teams in the industry, and a number of our customers rely on them heavily when things do actually go wrong.
Yes, yeah, exactly. I've had an incredible experience with Aviatrix support, coming from working from all sorts of large, well-known organizations in the past, as nothing has been as good as what I've experienced here. It's truly incredible. So tell me about what we're going to be doing here today.
Yeah, so if you can see the screen, what I have here is sort of two environments. The one on the left is a very typical existing environment for an AWS customer, potentially a prospect for Aviatrix. And once we nail the architecture down, the Aviatrix architecture down, and you see a snapshot of that on the right, the orange icons, the circular icons depicting Aviatrix gateways, the customer essentially builds that architecture out. The question that comes next is, how do I migrate my existing environment on the left over to the right? And really, what the customer is asking there is, how do I migrate my VPCs that host my production workloads over to the new architecture, with minimal impact, with the ability to, roll back if things go wrong, and crucially to be able to do it in a phased approach, which means do it, on a per account basis, do it on a per VPC basis, depending on, customer scheduling.
Right, right.
So let's talk about the actual process of migration, the steps involved to ensure minimal impact during this migration. Now, keep in mind the example that we covered today is using a AWS Transit Gateway moving over to the Aviatrix Transit. Now, having done this across multiple enterprises, I can tell you that there are a number of variations possible, especially starting out where existing customers may be using a legacy vendor based traditional transit VPC solution. There are even customers who rely on VPC pairing based solutions.
Mm-hmm.
So there might be variations of the existing architecture, and this strategy works across all those variations.
Cool.
So let's focus down to a single VPC and let's look at the actual steps involved. So in this, and I have a short demo right after this, where we will see how VPC2, which is right now connected to the AWS Transit Gateway, will be migrated over to the Aviatrix Transit on the right.
Mm-hmm.
And the way this is done is we look at the VPC structure and essentially the routing structure within the VPC, which is how many route tables it has, what is the subnet to route table mapping, and things like those.
Right.
Once we have a handle on those, the core strategy of moving traffic over to the new hub, to the Aviatrix Transit, involves replicating the existing route tables, right? So the first step we do is we look at how many route tables there are, what kind of route tables there are, private or public.
Mm-hmm.
We replicate those route tables and we associate those route tables with the Aviatrix Transit, which means during the transition, you have the VPC dual homed to both transits.
Yeah.
So you will have the VPC connected to the existing AWS Transit Gateway, and you will have the VPC connected to the Aviatrix Transit as well. The key is that there is a separation of which route tables are connected to both hubs. In this arrangement, the traffic originating or destined to the VPC is still flowing through the AWS Transit Gateway. The actual cutover of traffic involves switching the subnet to route table mapping within the VPC. So starting with the current setup where subnets are mapped to route tables that are associated with the AWS Transit Gateway, we flip those subnets over to the new route tables that were created and attached to the Aviatrix Transit.
Yeah, that makes a lot of sense, Abhishek. So one question I have is, I mean, you could do all this manually in the AWS console and whatnot, but I'm assuming that at this point, the Aviatrix Professional Services organization has done all this through automation, probably a mixture of Terraform and APIs, right?
That's right. This can be done manually, but we've done this for enterprises who have hundreds of VPCs, and the manual process just doesn't scale. So we've built automation that actually takes care of this migration process, and will be demonstrated right after this discussion.
Beautiful. Yeah, I know I've heard of some projects that you guys have done so successfully. We've moved hundreds and hundreds of VPCs over to Aviatrix Transit in no time. It's really impressive. Okay, so let's talk a little bit about the topology you have here. I see the old environment on the left, the new environment that we're migrating to on the right, but I also see a connection to on-prem and then a connection between the old and the new. Can you break this down for me?
Yeah, sure, Dana. So, like I mentioned, what you see on the left is the existing environment, and what you see on the right is the Aviatrix Transit architecture. The snapshot we have here is there are a bunch of VPCs that are in the process of being moved over to the new transit. So in this example, you can see VPC1 and VPC2 are still attached to the AWS Transit Gateway, whereas VPC3, VPC4, and a shared services VPC have already been moved over to the Aviatrix Transit. The key of doing this in a phased manner, of course, is building a connection between the two environments. And the way that is done is you can build IPsec tunnels between the Aviatrix Transit and the AWS Transit Gateway. And since AWS Transit Gateway supports ECMP over VPN, you can make multiple tunnels to increase the throughput. So for instance, we can easily have a pipe here by making multiple tunnels, which gives you over 20 gig.
Wow.
This varies from customer to customer, but really the significance of this is the traffic that you expect will flow between the old and the new environment.
That's brilliant. That makes a lot of sense. The great thing about this is that 20 gig pipe is awesome, right? But as you move more and more over from the left to the right side, the amount of that throughput required is getting lower and lower because now you're within the Aviatrix Transit, which has up to 75 gigabits per second of encrypted throughput. So it's usually not a problem. So this is a really clean way to do migration.
Correct. And obviously the end goal is once all your VPCs have been migrated over to the Aviatrix Transit, there is nothing left on the left side, right? Yep. So all of that actually goes away and you have a consistent Aviatrix Transit architecture, which is cloud agnostic.
Exactly. Beautiful, beautiful. What about that data center connection? Was it originally on the TGW? You've moved it there, or what's the deal with that?
Right. So customers during this migration will often move their data center connection over to the Aviatrix Transit as well. Keep in mind any inter-region, inter-cloud connections or data center connections. This is all shared infrastructure and can be done ahead of time.
Awesome. I want to see this in action, Abhishek. I'm so excited. So let's see how you're actually executing this process.
Yeah, sure, Dana. So the example I have here, and to demonstrate the minimal impact during migration, what we are going to do is we have two VPCs that are still in the old environment attached to the TGW. What I have is an instance in each of those VPCs. And what we're going to do is we're going to initiate a ping from one VPC to the other, which will right now, before the migration, essentially go to the AWS Transit Gateway and go to the destination. The script we have, the automation we have that migrates the VPC, what will happen is essentially VPC2 will be migrated over to the Aviatrix Transit. And what we'll see is through the ping drops that the impact during this migration is minimal. So VPC1 will continue to ping VPC2, but now the traffic will go to the AWS Transit Gateway, will go over the IPsec tunnels to the Aviatrix Transit, over to the spoke gateways, and then VPC2.
Okay.
And through this process, we'll see that ballpark the impact is around 10 seconds.
Okay. And all the routing for this transition will happen seamlessly by the controller, right?
Correct. The automation takes care of the process that we discussed earlier, which is sort of replicating the route tables within VPC2 and then the actual traffic switchover by flipping the subnets over to the new route tables, right? The script will also create spoke gateways in VPC2 and attach them to the Aviatrix Transit. So before we make any changes, like I said, let me start a continuous ping. And as you can see, this is essentially going from an instance in VPC1 over to an instance in VPC2.
Yep.
Right now, it's attached to, both the VPCs are attached to the AWS Transit Gateway, and we can measure the impact when we actually do the transition. Now, over to the automation. So this is a basic execution, and this is used very often for the Aviatrix services team to go into an environment and understand the current environment. So what you can do here is, as you can see from the output, what's happening is this gives us a snapshot of the existing environment, all the VPCs, and then all the route tables and subnets associated with those route tables, right? So in this case, this output is specifically for VPC2, referred to as spoke 2 here. And we can see that it has 4 route tables two of which are private and two of which are public route tables. So let's look at what the migration script actually does. So running the same script with a few more options will actually initiate the process of migrating the VPC attachment over from AWS Transit Gateway to the Aviatrix Transit. Mm-hmm. And all through this process, we'll monitor the pings and see what our impact was.
Great.
So let's kick this process off. And so we just ran the script, and as you can see here, the script actually has completed the migration for the VPC that we provided as input. And as part of the migration, it created a spoke gateway in the VPC. It created, of course, a HA spoke gateway as well. And then it actually attached that spoke gateway to the transit. And what we can see from the continuous ping between those VPCs is that the only impact we saw, as you can see, 218, 19, 20, and then you see 8 ping packets that were lost, and then the ping resumed after the migration. So the only impact we saw was around 8 or 9 seconds during this migration.
Yeah, that's incredible. That's really, really awesome. In the script, you could input all sorts of VPC IDs, and then it would move them all as a part of the script, right?
That's right. So I mentioned this at the beginning. Each customer does it on their own schedule, and there is flexibility in terms of which VPCs, how many VPCs a customer may choose to migrate in a single maintenance window. So the granularity is at a per account basis. So you could choose to migrate all VPCs in a single account, or you could actually choose to specify which VPCs, and only those VPCs will be migrated.
Gotcha. Abhishek, I noticed that after the migration, the latency went up. It was, at a consistent 0.9, but now it's at a consistent 2.9 or 2.5. What's the deal with that?
Right. That's a good catch, Dana. And what that actually shows us is at this stage, both the VPCs were connected to the AWS Transit Gateway. Once we did the migration, the increase in latency, and it's barely a millisecond, but the increase in latency is because now the VPCs are separated by IPsec tunnels. So the path is somewhat longer. It comes to the AWS Transit Gateway, goes over the tunnel to the transit, and then goes to VPC2.
Okay.
Once all the VPCs, in this case VPC1, is also moved over to the Aviatrix Transit, that latency will actually go back down to under a 1 millisecond.
Okay, makes sense. Yeah, it just jumped out at me. And I mean, honestly, going from the 0.9 to the 2.5, whatever, is negligible, right? It's not even noticeable by the app. So I was just curious about that. That's a good point.
All right. So the migration is completed, but let's take a quick look at some of the things that sort of happened in the background, things that the automation took care of. The first thing to note is if you go to multi-cloud transit list and you switch over to the spoke tab, VPC2 now shows up as a spoke. Mm-hmm. And this is based on the migration that was done. Mm-hmm. The other thing you can see from the Aviatrix controller is, so these are 4 IPsec tunnels. These are the tunnels that connect the two environments. So these are IPsec tunnels between the AWS Transit Gateway and the Aviatrix Transit. And as we mentioned earlier, you can actually scale these up to 8 if your bandwidth throughput requirements between the two environments is higher.
Got it.
The other thing to note from the AWS console is, so this is the VPC2 that we just migrated over. Mm-hmm. And what you can see here is at the start, VPC2 essentially had 4 route tables. Mm-hmm. And what you can see here is that the automation has replicated those route tables and then actually switched over the subnets to the new route tables, completing the migration. So what we do here is we actually leave out the route tables. And this is primarily done so that the customer has an option to roll back to their existing routing structure if things go wrong. So after the migration, we'll work with the customer to verify everything is working. And in case there is something in the environment that we can't figure out, the option to roll back exists. And all that needs to be done is the subnet to route table association just needs to be moved back, flipped over to the old route.
Oh, it's so easy. It's so easy to roll back if you needed to. That's awesome. I love it. It's cool that your team has thought this through for our customers. This is really powerful.
Yeah, and so like I said, right, the three key requirements from this migration process, and we've sort of demonstrated all three, is minimal impact, as we saw less than 10 seconds of impact per VPC. The ability to roll back if we run into an issue and cannot figure what's going on. And third, the ability to do this in a phased manner, which is, at one VPC at a time, 10 VPCs at a time, all your VPCs together.
Awesome. Abhishek, this has been amazing. I love it. I love how you guys have made this so simple for our customers to move away from the do-it-yourself, inefficient model of managing transit in the cloud to the automated, intelligent, controller-based model of transit in the cloud. We can do this for so many customers so quickly, and they can realize the benefits in the same day. Right? This is just unbelievable. You guys have done a fantastic job. Thank you.
Yeah, Dana. We love doing this for customers. We've done it for a bunch of enterprises who've already moved to the Aviatrix Transit, and we look forward to working with potential Aviatrix customers.